Woohoo! Welcome back. Today we're going to be talking about factoring. And the key to factoring polynomials is to remember to count the terms. So that's the key right there. Woohoo! Okay, so we're going to start in. And the first rule of Factoring Club is greatest common factors. Always try this first. You don't have to do this first, but it's a lot harder to try to do it at the end. So I encourage you to check to make sure there are no common factors before you continue on with the rest of the strategy. So once you know there's no common factors in the rest of them, then you count the terms. And we break these down into different categories according to how many terms there are. So if there are two terms, you see something plus something, or perhaps something minus something, right? You've got, or possibly even the opposite of something minus something. I mean, there are a few different combinations. Basically, if there are two terms, the patterns that we know how to factor fall into sum or difference of squares, or sum or difference of cubes. And usually this is pretty straightforward. You just look at the exponents and they're either going to be 2's or 3's. But there is an example later on. Sometimes you'll end up with an exponent like 6. 6 is divisible by both 2 and 3. So you could look at it both ways. And so I'm going to offer a strategy for that. So two terms usually is very exciting because it means you could just use the formula or you use the fact that a sum of two squares can't be factored and then you're done. Woohoo! Now the cubes, these two formulas are really persnickety. They're one of the ones that people have a hard time memorizing. I would recommend memorizing them together. A cubed plus b cubed versus a cubed minus b cubed. So whether there's a plus or a minus in the middle. And basically they both follow the same formula, the same layout. So a cubed plus b cubed starts with a plus b. A cubed minus b cubed starts with a minus b. The second part is going to be a longer factor. And this looks a lot like a perfect square, except it's missing that 2 in the middle. So if we come down here for perfect squares, we see that it's 2ab or minus 2ab. And here it's just ab or plus ab, minus ab or plus ab. But the way to remember this is if you've got the a plus b, then you're going to have a squared minus ab plus b squared. So the minus pops in here. If you already start with a minus b, it's all pluses. So that's the way I know how to memorize it. You can memorize it in other ways. These formulas don't come up that often, but when they do, it's really hard to factor these until we get on to the further along, about halfway through this class. We'll talk about other ways to factor things. Once we get to that point, these formulas can be helpful, but you'll have other techniques too. So for right now, this is kind of it. Now for 3 terms, I skipped one. In the olden days when there were dinosaurs running around, we had something called trial and error. And nowadays we have something called the AC method. And some people even learned the X method. So we will talk about trial and error and the AC method. I also have a video about the X method if you'd like to use that. The X method is actually the AC method, just set up in a slightly different way to make it easier to remember the steps. So that's pretty cool. Or if you look into it, if there are 3 terms, something plus something plus something, every now and again, you might have a perfect square. And so this is going to be the reverse of the formula that we were just studying when we were multiplying things out. And that is what happens when you've got a plus b times a plus b, or a minus b times a minus b. So those will be very special cases, but if you know this formula and you recognize it, it saves you a lot of time. Now, for 4 terms, this is going to be a method called grouping. And there isn't a formula here because it's a technique. So I'll show you how to do this in the video. It takes a little bit of practice, but it actually goes, it seems like, oh no, 4 terms would be the worst. It turns out that 4 terms is actually not that bad. And in fact, 4 terms is often better and easier to work with than 3. So the AC method and the X method both use grouping in them. You take a 3-term polynomial and you actually create a 4-term polynomial to solve it. Now we're going to keep factoring until, and this is so awkward, but usually folks recognize what I'm talking about in the example, so we'll point it out. But basically you have to keep factoring until x doesn't appear to a power greater than 1. So no x squareds, no x cubes, no x to the 4th. So you got it down to just x, as many as you need, or all the factors are prime. So there are going to be some x squareds and y squareds and a squareds. Those factors will be prime. A prime example, see what I did there, is in the sum of cubes. A note for these two is that the result here and here are that these two polynomials are prime. Because it's missing that 2 in the middle, we can't factor it any further. Now, when I say these are prime, I mean they're prime over the real numbers. Once we study complex numbers, we can expand our concept of what is prime and what's not prime. But for right now, we won't be able to go any further. So even though that you may end up, because of this formula, with an x squared, you won't be able to factor it any further, even with the quadratic formula. And the last thing, you check by multiplying out. So if you're ever not sure, you think you've got a good factorization, but you're not sure, multiply it out using all the techniques of multiplying polynomials. Okay, woohoo! So with this in hand, let's go ahead and try a few examples. So usually the instructions will be to factor completely. Sometimes you'll just see the word factor. It means the same thing. You have to factor it completely. Don't stop till you're done. So, first one. Now, it's easy to jump right in and say, oh, 2 terms. 2 terms means a difference of squares. I know how to do that. 4 is a square, 64 is a square. Let's see if I can kind of squish this in so we can actually see it. Can I do this? Kind of. Sorry about this. Everything's dancing around. Very excited. Math is very excited. Okay, here we go. So this looks just like this format. And it would be fine to jump right in, except always try greatest common factor. So is there a number that goes into 4 and 64? And the answer is yes. 4 goes into both of them. This is 4s squared minus, and you may need to use a calculator or just be practicing your times tables or your exponents, your powers. But this is going to be 4 times 16. Because we see that there's a 4 in each of them, there's a 4 here and there's a 4 there, we can factor that out and get 4 times the quantity s squared minus 16. Now, this does 2 things. One, you're required to do this. So this is great to get it out of the way before you do the harder work. And the second thing is these then become simpler to deal with. Rather than 4s squared and 64, we're dealing with s squared and 16. This is a difference of 2 squares. And here I'm going to switch to using brackets because I'm going to use brackets and parentheses. And it's helpful if you remember that 16 is 4 squared. So we can see this is s squared minus 4 squared. That is that pattern of something squared minus something squared. If it has that pattern, we can rewrite it like this. I'm going to have to cover this up. Sorry about this. So I've got 4 on the outside and s squared minus 4 squared, on the inside. And so that's going to follow the pattern s plus 4 and s minus 4. Let me write that down and let's see if I can get this squinched in real close so you can see it. If we've got a squared minus b squared, that factors as a plus b, so s plus 4, and then a minus b, s minus 4. And this is the final answer. And you don't have to include the big bracket in it if you don't want to. You're allowed to if you'd like to. It's your choice. Matter of style. Woohoo! We did one! Yay! One's down. Okay, let's keep going. Let's see if we can find some more. Okay, I am going to look at number 2 and realize that I put this as number 2, but I want to skip it for right now and go on to number 3 because number 3 and number 2 are really similar. So I want to look at number 3 and say, right off the bat, again, if you're looking at this and you're looking at your formula sheet, which don't quite fit together, so it looks like an of squares, but this is a sum of squares. We've got a squared plus b squared. You could see, oh, a squared plus b squared. That's looking like a sum of squares. So normally we'd say it can't be factored. But right above it, in bold letters, always try this first. Greatest common factors, or eatest common factors is what it looks like. So is there anything common between these two? And the answer is yeah. 16 is divisible by 4. It's 4 times 4, right? And then I say, oh, wait a minute. I got a 4 over here. I got a 4 over here. Woohoo. I'm going to factor out that 4. Greatest common factor. And then I get r squared plus 4. This 4 comes down here. And the r squared comes down there. If that makes sense. I'm not sure I like the way I wrote that. Let me see if I can tidy that up a little bit. I'll just draw the arrow from the r. So now this part is the sum of squares. And since they don't have anything in common, this is just 2 r's multiplied together. This is some 2's multiplied together. There's nothing that overlaps, nothing in common. So we stop there. And our final answer is just 4 times the quantity r squared plus 4. And we know that we're done because the sum of squares means that this is prime as long as we factored out any common factors. Okay, woohoo. So, you guys ready? Dun, dun, dun. Let's try going back to number 2 now. Number 2 is written in a really interesting way. And whenever you come across something that's been written in a really interesting way like this, I encourage you not to change the format, to look at how it's written. It's very tempting to say, oh, I've got x minus 5 inside a square. I should multiply that out. You're allowed to do that, but if you do that, it'll be harder to do the next step, believe it or not. This is actually a favor, even though it looks really intimidating. And the reason for that is, basically, this has been written as a squared minus b squared. And that is the difference of squares. That's this one right there. So let me go ahead and show you what I mean by this. I'm going to go ahead and use brackets. To write it like that. And once I put that in parentheses, perhaps it's easier to see that a squared minus b squared. It's something squared minus something else squared format. And that means that I can use this formula to factor as something plus something and something minus something. So what does this look like? This looks like x minus 5 plus y and x minus 5 minus y. Now, this one's a lot more complicated, and so it may take a little bit of time to take a look at it and really let it marinate and think about it. But basically, we're splitting this into those two pieces. And Notice that each of the pieces, although complicated, don't have the squares anymore. They're just straight up. They're just the thing itself, the x minus 5 and the y. So if you would like, you can leave it like that, or you could write it as x minus 5 plus y, and x minus 5, oops, my hand got excited. My hand was like, yay, we're done. We're not done. X minus 5 minus y. You can write it like that. I'm going to put a little or here because I think this is a good answer as well. I'll write it again so I can put a box around both of them. Now, when you answer this question, you could write it either way. Since they say or, it means you don't have to do both, and you can pick one, preferably without the rabbit fur. There we go. So you could pick whichever one is easiest for you to read, looks the best, makes the most sense. I would say this is nice because it remembers that x minus 5 was separate from the y, but honestly, you don't have to keep it that way. So either one would be acceptable. Okay, woohoo! I'm going to end this video here. In the next video, some more examples. You can almost see them through the paper. Ooh, a little ghostly preview. Okay, woohoo! And I'll be back with the next video full of examples. Math on. You're awesome. Woohoo!